This is the brief on the fundamental components of core computer architecture. Okay, so if we want to execute the code we write or design those really big distributed systems, we first got to understand the basics, right? We're talking disk, RAM, CPU, and cache, and really how they juggle keeping data safe versus getting it fast. First up, there's this big trade-off between disk and RAM. Think of your disk like an SSD or an old-school hard drive. It holds tons of data, terabytes maybe, and keeps it even if the power goes out. Persistent. But it's kind of slow, relatively speaking. We're talking milliseconds to get data. Then you've got RAM, way smaller, usually gigabytes, and poof, data's gone on restart. It's volatile. But the payoff? Speed. RAM is much faster, operating in microseconds. Could be like 1,000 times quicker than the disk. All right, second, the CPU. That's the brain crunching numbers, running your code. Now, the CPU is so fast, it's often waiting around, even for that speedy RAM. So it uses this thing called cache. It's tiny, just megabytes, and volatile like RAM, but it's baked right into the CPU itself. Cache is the absolute speed king, operating in nanoseconds. It holds the bits of RAM the CPU uses most often, making everything run way smoother. And finally, single computers, they have limits, especially CPUs. We had Moore's law for decades, basically. CPUs getting twice as powerful every couple of years. But that whole trend, it's kind of leveled off. So because one CPU can only do so much, engineers have to string multiple computers together, making distributed systems to tackle really huge problems. Getting these core trade-offs, speed versus cost versus keeping data safe, it's just crucial when you're building any system that needs to grow.